Hello everyone, welcome back to my channel. I'm Nandini. Today I'm back with a new topic. Today I'm going to discuss about radial basis functions, a comprehensive guide. Welcome to this presentation and radial basis function, that is RBFs, a powerful tool in machine learning and approximation theory. RBFs are versatile functions used for approximating data and creating models in various applications, including regression, interpolation, and classification. Next, let us see what are radial basis functions. The definition is radial basis functions are real valued functions whose output depends solely on the distance from a fixed point. This point is referred to as the center of the function. Key characteristics are RBFs are characterized by their radial symmetry. This means that their value at the given point depends only on the distance from the center, not on the direction. Next, let us see some of the properties of RBFs. First property is radial symmetry. The output depends only on the distance from the center. Second is the smoothness. RBFs are typically continuous and differentiable. Third property is positive definiteness. Some RBFs possess this property which ensures the existence of the solution. And the fourth property is universal approximation. RBF networks can approximate any continuous function. RBF kernel functions. First function is the Gaussian kernel, one of the most common RBF kernels, and it is bell-shaped with the output decaying exponentially as the distance from the center increases. Second function is the multi-quadratic kernel, defined by a square root function. This kernel has the steeper decay than the Gaussian kernel, leading to sharper approximations. Next function is the inverse multi-quadrate kernel, a more localized kernel, often used for approximating functions with sharp features. And the last function is a thin plate spine kernel. This kernel is particularly suited for interpolating scattered data points. Approximation with RBFs. Data points. RBFs can approximate data points by fitting a smooth function through them. And approximation function. The RBF network combines the contributions of multiple RBFs to generate a smooth approximation function. Interpolation. RBFs can be used in interpolate between data points effectively, creating a continuous function. RBF based interpolation and regression. Let us see what is interpolation and regression. First is the interpolation. RBFs are commonly used for interpolating data points, providing a smooth and continuous function that passes through all given data points. Next, what is regression? RBF networks can be used for regression tasks, fitting a function to a data and predicting the output for new input values. Next, advantages and limitations of RBFs are advantages. RBF networks are effective for approximating complex functions, offering flexibility and accuracy. They can be easily generalized to higher dimensions, making them suitable for complex programs. Limitations are choosing the optimal RBF kernel and parameters can be challenging. Training RBF networks can be computationally intensive, especially for large data sets. Next, applications of radial basis functions are: first function is a machine learning, second function is regression and interpolation, third function is classification. Next, the fourth function is image processing, fifth function is computer vision. Some of the advantages and disadvantages of radial basis functions are: advantages. RBF networks are versatile and powerful, capable of approximating complex functions. They are easy to generalize to higher dimensions, and they offer flexibility in choosing the RBF kernel and parameters. And some of the disadvantages are: choosing optimal kernel and parameters can be challenging. Training can be computationally intensive. They can be prone to overfitting, particularly with complex datasets. Let us see the conclusion. Radial basis functions offer a valuable tool for approximating data, interpolating functions, and solving various machine learning tasks. They offer flexibility, accuracy, and potential for handling complex problems. And understanding the advantages, limitations, and applications of RBFs empowers you to leverage their power in your own work. This is all about the radial basis functions. So thank you for watching. Please do like, share, and subscribe to my channel.